Okay, I want to start off by just saying something that as a reminder. Any whole number can be rewritten into an equivalent with a decimal point and lots of zeros after the decimal place. So if I wanted to say that 1 equals 1.0, I could do that. Or 1.000000. As long as there is a decimal point and only zeros, it's the exact equivalent. Same thing with 425. 425, put in the decimal point, and then as many zeros as I like. I can do that the same as over here. So let's say that we have 1/5, where 1 is our numerator, 5 is our denominator, and we would set the problem up like this. 5 goes into 1 a certain amount of times, and that would be our quotient or our answer. But unfortunately, 5 doesn't go into 1 a whole amount of times because 1 is just not big enough. It's much smaller than 5. So it doesn't mean that we can't do the problem, it just means that we need to be a little more creative. Okay, so I've rewritten 1 as 1.00. It's the equivalent, and I can do that. So now let's think of this as not just 1, but $1. And I'm going to split $1 into 5 different equal parts, equal groupings. And so while I can't divide 1 very easily into 5 different sections, do you see how it's easier to think about dividing $1 into 5 different sections? Because $1, you could split it up. Certainly, if you wanted to divide $1 into 4 different sections, you could do that. That's a quarter. Okay, so 25 cents is a quarter of $1. That's why they call it a quarter. So I would suggest thinking of these whole numbers as maybe different versions of themselves. Still, we're still dealing with 1 of something. We're just dealing with $1. Okay, now dollar has cents. Okay, so you could think of it as $1 could be, you could rewrite $1. You could rewrite $1 as an equivalent. What's an equivalent of $1 is 10 dimes. And you could divide 10 dimes by 5 if you wanted to. Okay, so 10 dimes divided into 5 different groups. So let's just imagine that. So 1, 2, 3, 4, 5. Okay, so these are 10 dimes. Each one is worth 10 cents. Okay, each one of these dots is worth 10 cents. Okay, so let's divide them into 5 groups worth. Okay, so if I wanted to divide them into 5 equal groups, I know that I'm going to have 5 groups. I just don't know how many dots I'm going to have in each group. I do need to have a same amount of dots in each group. So let's see. So this would be, well, anyway, you could do sort of the bean counting kind of way, but in the end, you're going to have 5 groups of 2 because 5 times 2 is 10. Okay, so you'll group these 10 dots. Each dot is worth 10 cents, 1 dime. And so that is how much each group has. Each group has 2 dots. These 2 dots are worth 2 dimes or 20 cents worth. Okay, so this whole group is worth 20 cents. Okay, now let's go back to over here. All right, remember how we took 1 and we turned it into $1? Well, that is going to be in terms of 100 cents, okay? And so if we divide 100 cents into 5 different parts, or 10 dimes into 5 different parts, we get 20 cents each, okay? So each of these groups is worth 20 cents. So what we're going to do is our original problem here was in terms of dollars. So how do you write dollars? 20 cents in terms of dollars? 20 cents is represented by 0.20, okay? And so that is going to be what our quotient is. So our quotient, so 5 goes into 1, and we creatively thought of 1 as now being $1, but now we can say, oh, okay, so that's 0.20. Okay, so we're going to get into the mechanics of how to actually do this, but I wanted to go through a visual way of how we could ultimately try to get a large divisor into a smaller dividend. And we'll continue in the next video.